Alright, so we're back for the postulates. So there's going to be a series of videos talking about postulates. So in the last video we talked about the corresponding parts of congruent triangles are congruent. So you can now use this in your proving. We've showed it, and so this is like a postulate as well. So for this postulate and the rest of these postulates, we're talking about how triangles can be proven to be congruent without knowing that all sides and angles are congruent. So we don't have to prove that every single side and every single angle of two triangles are congruent, because we have actually proven that there are shortcuts pretty much. So for example, which is going to be our first example, if we didn't know that these angles are congruent, let's say that we didn't know that these angles are congruent, but we did know that the sides of these two triangles are congruent. Here's the thing, if the sides were congruent with each other, well, the thing is, if they are the same, so like this length right here, if that length right there, that length will vary depending on the size of angle C. For example, if we made C larger, then that would make BA a larger, the length of AB larger, right? If angle B was smaller, then that would mean that CA, this line segment, would be smaller. So pretty much what I'm saying is that the length is determined by the angle, the opposite angle to it. So knowing that, if we know that all sides of a triangle are congruent, well, that must mean that their angles must also be congruent, and therefore the triangle itself is congruent. So we don't have to always know the measure or whether or not the angles of two triangles are congruent. If we know that each side is congruent, then we know that the triangle is also congruent. So that's what this postulate states. This stands for side, side, side. So we call it SSS postulate. So side, side, side postulate. And this states if three sides of one triangle are congruent to three sides of another, then the two are congruent. So if three sides of one triangle are congruent to three sides of another, then the two are congruent. So let's go over this example right here. Now in this example, there are some theorems that we will use that we haven't yet talked about, and I apologize for that. We haven't talked about them, and we will talk about them soon. Okay, so in this first example, it says that line segment AB is congruent with DB. C is a midpoint of the line segment AD, right there. And we want to prove that these two triangles are congruent. So here we have a partially completed two-column proof, and we just need to fill in the rest. So AB is congruent with DB. Now that was given to us. So we're going to write this in the reasons column that this was given. And that C is a midpoint of AD, well, that was also given to us. Okay, so now here it gives us the reason, the midpoint theorem. Okay, so we haven't gone through the midpoint theorem yet, but we will later on in this video, or a series of videos. So the midpoint theorem basically just states that right here, since C is a midpoint of AD, then by definition pretty much that must mean that these two sides are congruent, because that's what it means to be in the middle, right? So that means that this segment right here is equivalent to the length of this segment over here. because it's the middle point, right? So by the midpoint theorem, we can conclude that the line segment AC is congruent with the line segment DC. So this segment right here is congruent with this segment right there. So I'm going to draw a line through them, signaling that they are corresponding and congruent. Now the reflective property. We talked about the reflective property in part A, but so this line right here, BC, is a shared line. And by the reflective property, we can conclude that BC is congruent with BC. Okay. So, because we know that all three sides of these two triangles are congruent, we can conclude that these two triangles are congruent, and that's by SSS, side, side, side postulate. Because again, these sides are congruent, these sides are congruent, and this side is congruent with itself, right? So we prove that all three sides are congruent, and we don't need to prove whether or not that these angles are congruent. We don't need to do that. We just need to prove that all the sides are congruent in this case to prove that the triangles are congruent. Okay, so that's it for the side, side, side postulate, and in the next video we'll talk about the side angle side postulate.